Greetings, sports fans! I am your guest instructor, Hannah K. Mitchell, but you can call me Invisible Ring if you want. Today I am here to tell you all about Newton's 3 laws of motion. This presentation is targeted towards middle schoolers from grades 6 to 8, but it might contain some elementary school and high school content as well. I think this is a presentation that everyone can learn from and enjoy. But speaking of elementary, I bet you are wondering who let this Poptropica in here and why. Well, viewers, aside from the fact that the online game known as Poptropica has been known to have educational value, I happen to be a die-hard Poptropica fan. More importantly, though, in my opinion, Poptropica avatars are way more fun to use than Facebook avatars for presentations. Now that you know the weirdest facts about your new instructor, let's start the slideshow and get to Newton's first law of motion. Let's get a move on, jockeys! Okay, as quote, an object at rest tends to stay at rest, while an object in motion tends to stay in motion in the same speed and in the same direction unless acted upon by an unbalanced force. Take this kickball and this kickball player, for example. The kickball is not going anywhere, and it won't be going anywhere either. Not until the player runs up and kicks the ball. The kick is the unbalanced force that changes the ball from rest to motion. But if the ball is heading towards the direction of the other kickball players, somebody is going to catch the ball. This is the unbalanced force that changes the ball from motion back to rest. By knowing Newton's first law of motion and figuring out how to apply it in sports to your best advantage, you can be the top Poptropican in your gym class or extracurricular sports activity every day of the week. Newton's second law of motion is next. But I must warn you, this slideshow will continue in the same speed and direction unless the unbalanced force of technical difficulties occur. So, I hope that you can keep up with this and I'm not going too fast for you. The second law of motion is an equation. Force equals acceleration times mass. When we think of force, we might think of punching bags or wrestling matches or even the Star Wars force, but that's not all there is to it. A force, by definition, is a push or pull or any interaction between two objects. As you can see, this Poptropican is about to have an interesting interaction with this punching bag. Put 'em up, pro puncher! Let's look at another example. During dance parties or football games, you might see a beach ball getting tossed around. Every now and then, someone might throw this ball too hard and hit someone by mistake, but it would barely hurt the person, if at all. This is because the beach ball is super lightweight, and the mass is very small. So although the acceleration is at large, the force is not strong enough to cause any damage. Now, if someone were to throw a much heavier ball, like, say, a disco ball with the same acceleration as the beach ball, well, the mass is much larger, making the force of the ball that much greater. It is very unlikely to find someone throwing a disco ball because it's very dangerous and can put someone in the hospital. But in the rare occasion someone does throw a disco ball at you, it's not a beach ball, so just run. Everyone get all that? Good. Now for Newton's third and final law of order. I mean motion. This is probably the toughest law to know, but by the time you know this one, your sports skills will be in perfect running order. The third law says, with every action, there's an equal and opposite reaction. If you've ever been on a plane or in a car that suddenly thrusts forward, you may find yourself being pushed backward the moment it happens. The vehicle's takeoff is in the action, and your body reacts with equal force and in the opposite direction. So hang on tight, because this rocket is really going to fly. Let's take a look at another example. At a basketball game, each player dribbles the basketball once they have it. To bounce the ball, each athlete pushes the ball down to the ground. Once the ball hits the ground pushes the ball back up in the air. If you're like me, you might ask yourself, how is this possible? How can the floor push something if the floor doesn't even move? It can't just shove other people out of the way like we can. How do we know if the floor is pushing on anything? These are exactly the questions I have asked myself over time. Sometimes I still have trouble understanding this concept, so think of it this way. If the floor didn't push back up on the ball wouldn't bounce. The bounce is proof that every action has its equal and opposite reaction. Now that you know about Newton's laws of motion, here's a hands-on activity you can apply them to. It's a simple activity about the ramp of a car. Sorry, sports fans, it's not a sport, but you can always go outside and kick a soccer ball or something after this presentation. For this activity, you'll need a toy car, a tape measure, and a few books. One of them must be hardcover. And you'll need at least 3 more other books that share similar thickness. Oh yeah, and don't forget a pencil and paper for taking notes. If you need help figuring out which books to find, you can do what I did, and just find 4 identical books that are all hardcover. Here's step 1. Set a book down on either a table or a smooth, hard floor. It's important that you do not choose a carpeted or linoleum floor, as it may mess up your results. If there are no smooth floors to work with in your home, I recommend going out to a park or a backyard and use the concrete floor out there, like I did. So after you set a book down on either a table or a smooth, hard floor inside or out, lean the hardcover book against the other book to form a ramp. As you can see, this is a very shallow ramp, not very steep. But that doesn't really matter. As long as it forms a ramp, it works. Step 2. Take the toy car and put it on the head of the ramp. Just hold it still like so. And then on step 3, let go of the car. Wait for it to stop rolling, then you take the tape measure and measure the results in inches, from the head of the car to the tail of the ramp. Then you write down the results. Step 4 is to repeat the process by stacking a new book each time to make the ramp steeper. And then you measure how far the car went each time a new book was added. After you're done with this experiment and you're done taking notes on each car ramp trial, take a look at these questions and discuss them amongst yourself or your teachers or your friends or anyone around you. Just think about these questions for a little while. But don't worry, these aren't test questions. These are just extra questions to think about in your experiment. Alright. Do you understand Newton's 3 laws of motion now? That's good, because now you have to take a test on them. Yeah, I know what you're thinking. I bet you were thinking I was done with this presentation by now. But don't fret, the test is the last part, and it's only 3 questions long. It'll be over before you know it. Question 1. Friction and gravity are the most common examples of unbalanced forces. Which of them is responsible for stopping a football that is rolling along the grass? A. Friction, B. Gravity, or C. Both. You have 10 seconds. Go! The answer is A. Friction. Gravity doesn't play a part in this unless the ball is bouncing. Friction is not only what stops the rolling football, but also what stops the car in the hands-on activity. You think that was too easy? Don't worry, I think number 2 will be a little bit harder. Question 2. Which should you use to hit a kickball with? A baseball bat or a ping pong paddle? And why? Your hint is, assume that you are swinging the bat and the paddle with the same speed or acceleration. 30 seconds. Go! The answer is a baseball bat. The baseball bat is more massive than the ping pong paddle, which means the bat can put more force on the kickball than the ping pong paddle. This is indeed an unusual combination of sports equipment, but it's science, so it's allowed. Okay, now here comes the tough question. Question 3. There are two people in a game of tug of war, one on each side. One person is pulling the rope while the other is pushing off the ground. Both players have the same strength. Who will win and why? You have 35 seconds. Go! In case anyone is wondering, it is not a tie. The person that pushes off the ground will win. By pushing against the ground pushes back with that person. The other person who pulls back on the rope ends up pulling herself forward, in effect of Newton's third law. Newton's third law is the key to all games of tug of war. Great job, everyone. You're all done with the test. Take a minute to congratulate yourselves whether you got the answers right or you got them wrong but still tried. You earned it. To wrap this lesson up, Newton's 3 laws of motion have had a 100% success rate since they have been passed. The very reason they're called laws is because they have never been proven wrong. Good thing, too, because if they were ever proven wrong, then these laws would be broken. Just imagine if motion was outlawed. But I'm sure glad it's not. That's the end. Thanks for watching, everyone. Hope you learned something and you had a lot of fun.